Okay, so we've been kind of touching a little bit about polynomials throughout this chapter so far, but we haven't gotten strictly into it. We just kind of brushed the surface of polynomials. We've dealt with exponents and like the rules. We've talked about square roots and that stuff. And we did talk a little bit about polynomials because we kind of worked with those a little bit when we were combining terms and like foiling things. But now we're going to specifically get into just the polynomial side of things. So today we're going to talk about what makes something a polynomial, and kind of how we can combine polynomials as long as they have like terms. And then eventually we'll start getting into factoring in the next section. So today I just want to kind of have an overview of what is a polynomial and things that they're going to use when they talk about it, that like vocab words that we want to know what they mean, so that in a problem when you're reading the directions, if they start throwing out these words, you know what they're talking about. So we're also going to talk about doing operations with polynomials, adding, subtracting, multiplying. We probably won't get into dividing yet. That might be coming up in the future. So when we talk about the vocab of polynomials, that just means that as they get more complex, there's more things that we can look for or work with within our polynomial. We can name a polynomial a couple different ways, and so I want to be able to do that depending on maybe what it looks like and what I'm looking for. And then there's also going to be things like exponents, and there's going to be terms that we're looking at, and also coefficients and degrees and all these things that kind of come into play. So when you have a polynomial, this kind of is just showing you like a real generic overview of what they look like. And it looks kind of messy right now because there's just a bunch of symbols everywhere. But when you think about a polynomial, it's anything that starts to have exponents. So like x to the fifth power, x to the fourth, to the third, so on. And then there could be numbers involved. So like even something as simple as 2x plus 5, that's a polynomial. Because you start to have more than one term, and there's letters and there's numbers involved. There's operations that separate those things. But then they can start to get more complex. Like they could start adding a squared, add another x to the 5, minus 4. Like they could start making these really big, and they could start changing those exponents as well to something even larger than squared. When we think about a polynomial, there's something called a degree, and the degree is the highest exponent that you see. So sometimes it's deceiving when they write out polynomials because especially if you have like different letters being combined, like x's and y's, then you have to look at what is that number together, like the exponents that you have for each term, what's the sum. And sometimes they'll even put the polynomial out of order on purpose to try to make sure that you're paying attention to what has the highest exponent. Leading coefficient would be your term that's attached, like the number that's attached to the term with the highest degree. Because if I were to write it in standard form and have it be descending, that term would be written first. Usually the highest degree term goes first, and then we just go down one at a time. So what I mean is you start with x to the fifth, and then you would go down x to the fourth, x to the third, x squared, and so on down to just your regular numbers. And you don't have to have all those terms in there. Sometimes they're going to skip over some. But like I said, there's going to be times where they have them out of order. Okay, so here's what I mean. They might write something like this. X to the fifth plus 3x to the sixth plus x. That's an example of a polynomial that they might throw at you. And then they're going to ask you, what's the degree? What's the leading coefficient? What are some of these things that we've been talking about? To do that, though, you have to watch because they did, like I put it purposely not in order. This term here in the middle, that 3x to the sixth power, that's actually supposed to go in the front because it has the largest exponent. The sixes would be the degree, and then that 3 would become your leading coefficient. Okay, so from this term up here, my leading coefficient, I'll just abbreviate that, my LC would be a 3 based off of that polynomial. And my degree, I'll put that over here, should be 6. Again, just using that example. A constant term in a polynomial would be something that doesn't have a letter. So usually at the very end, like if you're going down one at a time with your x's, sometimes they'll have a term that doesn't have an x anymore, or whatever letter they're using, and that would just be your constant term. So it's just anything with a number. Like I said, we have something called descending order or standard form. That's when you rearrange your polynomial and you put it in order. So if I'm thinking about this one up here, instead of putting the x to the fifth first, I would actually put 3x to the sixth first, and then the x to the fifth, and then the x. Okay, but this could also look a whole bunch of different ways. So another example could be if I just start with just x's, x to the fourth, x to the third, x squared, so on. That's also considered descending order. So anytime you're working with a polynomial, I would make sure it's in that order first before you try to start answering any questions, because if you don't pay attention to what they did, you might miss the actual degree and leading coefficient if they hit it kind of farther down, because they will do that sometimes. So just try to make sure you're paying attention. Now, how to classify polynomials. If you have a single term, that's called a monomial. Okay, like think about the prefix there, like mono, that just means like single, like one person. So when we think about one term, it could be a number, it could be a letter by itself, it could even be like 3x. That would be a monomial because it's singular. Binomial would be two terms. So like x plus 5, 2x minus 3, anything that has two separate terms together, that would be a binomial. Trinomial has three terms. And then beyond that, we stopped giving them special names. We just call it a polynomial. So anything that has more than three, we don't have a special name for it. Okay, so now let's start getting into operating with polynomials. So we're first just going to start with adding and subtracting. We've got a couple of examples here. The first one is just an addition problem. And what I like to do is just kind of underline my like terms so I know what I can put together. And you can do this however you want. You may not need to underline your like terms. Some kids will like to highlight the like terms. You can do whatever makes the most sense for you. But also look for the one that's the biggest. So biggest degree. So in this case, I see an x to the third, and I think that's the largest exponent that we have, which means I should probably combine those first. So I have a negative 17x to the third here. What can I put that with over here? Yeah, the 16. What's that going to become together? Negative 1x to the third. Or you could just write negative x to the third. Okay. How about my 4x squared? Do I have anything to put that with? Nope. So that just comes down. Okay. How about my x's? I have negative 11x and 3x. What would those be together? Good. Negative 8x. And then last, negative 5 and negative 15. Negative 20. Okay, and I'm just color coding it there so you can kind of see why I got those numbers. Where did they come from? Now with subtraction, it's the same thing, but I would caution you with subtraction because this is where I see more mistakes happen because we miss the sign. We forget that that minus sign is going to affect everything in that second set of parentheses. So what I would almost even suggest that you do, especially if you've maybe had issues with subtraction in the past where you know you're going to miss a negative sign. You know yourself and you know you're going to forget to do something like that. I would almost rewrite that entire second set of parentheses and just change the signs of all of them because that's really what's going on there. Anytime you have a subtraction sign, everything after the subtraction sign is going to flip its sign. So I would almost think about rewriting this as a 5x. I'm not going to do anything with the first set. So I'm just going to drop all that down. And then I'm going to switch the signs of all of those other terms. So it's going to become minus 3x to the fourth plus 6x to the third minus 7x squared minus 2x and plus 11. Also in that case, I got rid of all my parentheses because I already took care of the minus sign. So I don't really have to think about it anymore. Now I start looking for like terms. Can we put anything with the 5x to the fifth? No. I'm just going to cross it off as I go here. How about negative 3x to the fourth? Does that have anything?
Another 3x to the fourth.
Yeah, it's got another negative, so that becomes negative 6x to the fourth. What would go next?
6x to the third.
Yeah, make sure we go down to that 6x to the third, because again, I'm thinking descending order here. Next?
7x squared.
Good, that doesn't have anything with it as well. Next?
And then 2x's.
What happens with those? they cancel out because they're opposite signs. So they're actually gone. And what do I have left?
11.
11. Okay, so do things like that. Like I crossed them off as I went. That helps me keep track of what I've already done and what I need to deal with more, especially when you have a lot of terms being thrown around like that. All right, so that's adding and subtracting. Pretty straightforward as far as just looking for your like terms. Just watch the minus sign there because it will trick some of you with those signs if you don't pay attention. Now let's get into multiplying. We've done a little bit of this already because we've been multiplying letters especially and like combining exponents. So we kind of talked about those rules already, so we should know how to handle this. For that first one, 11x to the third times 2x to the sixth, what would that become?
22x.
Good. You just multiply, and then with your x's, you make sure you add your exponents. Now, as they start to add more terms, and there's plus and minus signs being thrown in there too, you're going to have to start thinking about an organized way to multiply. When it's two binomials, like the second example is, two sets of two terms there, you can still just FOIL. And we've done that already with like working with those conjugates. We even did that today with our bell ringer. So I'm going to think about foiling here. What would be my first term if I multiply the pieces? Five x to the third times 4x would be what?
20x to the fourth.
How about your outside terms?
12x to the second.
Not 12. Outside terms.
10x to the third.
Yeah. Inside terms?
12x to the second.
And then last. Now, you had said 12x to the second first. That's not wrong, okay? Because you still probably had the 10x to the third after that, right? The only thing is then if they are wanting you to write it in descending order, you'll just have to flip those two terms around on the inside. So it's not incorrect to go about it that way, but just make sure if they're asking, write all your answers in descending order, that you check to make sure that you have to flip anything around like that. Okay, now the third one there starts to get a little bit more complicated because you're taking a trinomial times a binomial. Okay, now there's a couple ways you can handle this. You can still distribute. So I know some kids will like to do that. They'll want to take x squared and multiply by the 6x and the 7 and then like the middle term and everything. I show like my students last year when I was in Algebra 2, I would show them the box method to do this. And I don't know if you were with Mrs. Westhoff, she may not have showed you the box method. But how that works is you basically are going to make like a big rectangular array. So we're making a box basically. And across the top, I'm just going to put the first polynomial. So x squared plus 4x minus 3. And then I'm just going to draw columns to kind of separate those terms. Then along the other side, the left-hand side, I'm going to put my other polynomial, which is the 6x plus 7. Those of you who had me last year, does this look familiar? You remember doing this? Okay. The reason why I like the box method is, especially if you're maybe not a super organized person, that's just not how you kind of, roll with your life. This helps kind of organize things a little bit more for you. It also helps with the like terms because it keeps them diagonal from each other for the most part in your polynomial. So it makes it really easy to see what we need to combine. Now to fill in your boxes, you just start multiplying the elements together. So you take the first one from the top, the x squared, and you take it times the 6x, and then you fill in that box. So this first one would just be 6x to the third. And then you can either fill in across the top or you can go up and down. It doesn't really matter the order that you multiply it in, but just keep track of what you're multiplying together. So 4x times 6x, if I go across the top there, would be a 24x squared. And then 6x times negative 3 would be negative 18x. And then I'm going to do the same thing along the bottom. So it should be 7x squared, 28x, and negative 21. And then the last thing that we should be able to do is combine any like terms that we see. Do we have anything that can go with the 6x to the third? No. Then if you look, your x squared terms are diagonal. So it makes it really easy to see what you're trying to combine together. So what is 7 plus 24?
31.
31. X squared. My x's are also diagonal from each other. 28x minus 18x would be
10x.
10x. And then the last thing is that 21, the negative 21. Some of you maybe are used to doing like distributing. Maybe you take the 6x and you multiply it in. You take the 7 and you multiply it in. You're going to get the same answer as I did. As long as you're multiplying correctly and you're combining your terms correctly, you should get the same answer. So if you like to use that method instead, you just want to distribute, that's fine. If you maybe have never seen the box method before, that was your first time and you saw it and you kind of like it, you guys are able to use that as well. Okay, or even if you have used the box method before and you hate it, you can distribute instead. Questions so far? Okay. We're going to get into some special products. So just like with the conjugate, when we multiplied by the conjugate, like we did in our bell ringer today, and kind of that special thing happens with those middle two terms that they always cancel. There's going to be times where you have polynomials that look the same, but maybe there's like a minor difference between the two of them. And when that happens, when you multiply, there's always going to be this special pattern that shows up. Okay, so there's a couple of different cases here. The first one is called the product or the difference of two terms. And so this could be when you have the same exact polynomial twice, but one has a plus sign and one has a minus sign. Or they both have plus signs, they both have minus signs. So they look the same or they look slightly different, but as far as like the terms go, those match. When you start to multiply those things, certain ones will cancel off, certain ones will just double, and you'll kind of be able to start to recognize those patterns. The other thing that we'll talk about is getting into like trinomials, and there's like special rules with that too. So for this first one where it says 7x plus 8 times 7x minus 8, again, I got two binomials here that I'm multiplying. I would just think about foiling them. So your first terms would be 7x times 7x. Your outside terms would be a 7x times that negative 8. And then the inside terms are the same, but opposite. So this is a one that we can use a shortcut. Because I'm looking up here and it looks like this rule that I have written at the top. Same terms, one has a plus sign, one has a minus sign. So the shortcut is, instead of trying to do all that work with foiling, I can take my first term and multiply those together. So 7x times 7x is 49x squared. Then really I can skip over the inner terms because, again, they're going to cancel off. And I can go straight to the last term and square that as well. So 8 times 8 is going to be 64, and there's always going to be a minus sign in between them. Anytime that those signs are different, they're always going to have a subtraction sign in between your two numbers. What's something else that maybe you guys notice right now about those two numbers, 49 and 64? Have we seen those numbers show up before in class? You can square root them, okay? They're both perfect squares. Keep that in mind, okay? And be able to recognize those perfect squares, because eventually when I said we'll go into factoring, we're basically going to undo this. So if you can recognize perfect squares, it's going to make your factoring a lot easier when you start to get into these special cases. Now, how is the second one different than what we just did? How is this one, 2x minus 9 squared, different than the one up above? The parentheses are squared. So really this means 2x minus 9 times 2x minus 9. Right? Because it's the same thing squared, so it's twice. Is there a plus and a minus sign for this one, though? No. So the middle terms are not going to cancel off. If you come up here, it kind of falls into one of these two rules. In this case, it'd be the bottom one because it has a subtraction sign. So if you follow it, you're going to take your first term and you're going to square it. So what's 2x squared? 2x squared is 4x squared. Okay, and then it's going to be minus 2 times your a times your b. So the a term is 2x, the b term is the 9. So you're going to multiply those, and then you're just going to double it because you have the same inner term showing up 2 times. That's why we're doubling it. Same thing could be said if you think about foiling. 2x times negative 9 times 2x, you're going to get the same answer twice, so that's why we're doubling that answer there. So the middle should become 36x. Again, it's going to have a minus sign for this one because of the minus sign that we had originally. That kind of follows in the rule. Same with up here. If you have a plus sign, then that second term would become positive. Last thing then is to square your last term. What's negative 9 squared?
81.
81. Again, we see some perfect squares showing up there. Recognize those because you'll start to see that again when we get into factoring. Okay, last little piece here. You might have to do a combination of those operations that we talked about, like adding, subtracting, and then maybe there is multiplying in there. But now we're starting to see things with lots of letters, not just X's. So like this one, they throw in some Y's. So first one, we're just subtracting. Again, if you need to, because there's a subtraction sign here, think about distributing that minus into that second polynomial before you even do anything here. So I'm just going to rewrite this as x to the third. I'm not going to do anything to that first set. The second set, though, everything switches its sign. When you're looking at terms that have lots of letters happening, you can only combine them if the letters match and the exponents match too. So even if they both have an x and a y, if their exponents aren't the same, you can't combine them. So you have to kind of double check those things. Do we see anything we can put with this x to the third? Yep, so what really happens there? They cancel. So those are gone. Okay, can we put anything with this next term? It's an x squared and a y. Do you see any others, x squareds and y's? The 6 down here, kind of towards the end. So what's negative 4 plus 6? 2. So those become 2 x squared y. Okay, then kind of just following the order here, I've got a 5xy squared. Does that have anything to go with? No. And y to the third? Good. Negative 2y to the third. I think one of the questions I get about these kind of problems, especially with multiple letters, is how do I know what order to put them in? Like, how do I know what's supposed to go first, second, and whatever? Usually, I would say rule of thumb is alphabetical order. So X comes before Y in the alphabet, so you should probably have your X's first. And if you think about kind of like Pascal's triangle, we talked about that at the beginning of the school year. They had kind of a pattern with the exponents where they kind of would start high and then decrease, and then the second letter would do the opposite. That's kind of happening here. So this kind of resembles a little bit of what we saw with Pascal's triangle. Really, if you start to get into really odd cases where there's lots of letters flying around, as long as you have all the pieces there, I'm going to be fine regardless of what order they go in, because it starts to get a little bit tricky when they start to throw in a lot of letters. Okay, let's do this last one here. Think about foiling for this one. Or you can even use the box method on this if you liked that. It still works, even if you're just dealing with two binomials. What would be your first term? Outside? Good. Inside?
6xy.
And last,
Minus 2y squared.
is there anything we can put together?
Minus 7xy plus 6x.
So that should just become negative xy and then minus 2y squared. Good. Any questions?